Okay, so question number 13 is to draw the Lewis structure of phosphorus trifluoride showing all the lone pairs. So then all the following questions. Okay, so this is a two-part question. So let's just do it step by step. So first, for part A, let's draw the Lewis structure for phosphorus trifluoride. So let's find the total valence electrons, where phosphorus has 5 valence electrons, and fluorine contains 7, but there are 3 fluorine atoms, so we multiply it by 3, and this gives us a total of 26 valence electrons. So let's write phosphorus as our central atom, and then I'm just going to draw all my fluorines symmetrically around it, and I'll fill in all the lone pairs. So if I count out how many electrons I've drawn so far, I only have 24. So for my last two, I'm just going to add them as lone pairs. So now we need to find the molecular shape of Pf3. So if we look at our structure, we have one lone pair, and we have 3 bonded atoms. So if we use our helpful Vesper table, then one lone pair and 3 bonded atoms tells us that we have a trigonal pyramid molecular shape. So part B of the question, what is the Fpf bond angle? So again, let's use the table to see that it is around 109.5 degrees. And lastly, is it polar or nonpolar? So all the fluorines will have dipole moments going towards them, and the lone pair doesn't cancel it out. So because of its trigonal pyramid shape, then we're left with a polar molecule. Okay, so that answers all of the questions related to Pf3. So now let's do the same thing for sulfur difluoride. Its total valence electrons is 6 plus 2 times 7, which is 20. And if we were to draw out the Lewis structure, let's draw single bonds to fluorine, showing all of the lone pairs. So I have 16 so far. So the last 4 I'm just going to draw on my sulfur. So now we have the Lewis structure of SF2. So now the question asks for the hybridization of the central atom. So again, let's look at our sulfur. It has 2 lone pairs and only 2 bonded atoms. So according to the Vesper table, when we have 2 lone pairs and 2 bonded atoms, we have a bent molecular shape, tetrahedral electron geometry, and the hybridization is sp3. So sp3 hybridization. What is the approximal, is it polar or nonpolar? So we have a bent molecular shape. So because of this, the two fluorine atoms don't cancel each other out. So now we have another polar molecule. And lastly, for the approximate bond angle, it will also be 109.5 degrees. Okay, so let's see what the junior tutor said. Trigonal pyramid, 109.5. And they have a polar molecule, or SF2, Sp3. It's bent, and it's polar, and the bond angle is 109.5. Okay, so this solution is correct.